Today's lesson is on systems of equations and inequalities. Today we're going to focus on solving them by graphing. So a system is when you have more than one equation. Infinite number of points live on each line, but only one point lives in the system so that it is a solution for both equations. So what we're looking for are where the two lines cross and meet at that one point, the one point that they share. And our goal is to find that one point. So if we're going to solve this by graphing, I have to take my first equation and solve it for y. And then I have to take my second equation and solve him for y. Right, that's a negative. So to graph the first guy, I'm going to go up to 4 and put a dot. Ooh, that's off. Let's try that again. And then I'm going to go down 1, right 1. And very carefully draw my line. For my next equation, I'm going to go up 3. And then my slope is down 2, right 3. So down 2, right 3 puts me right on that point. And then another one goes there. And then there. So to draw that, kind of missed my points. But they are going to cross right there. And that would be the point 3, 1. So that is the solution for this system. The nice thing you can do is you can check this, since 3 is your x value and 1 is your y value. You can plug your 3 and your 1 in here and double check it to make sure it works. So if I look at the first one, what's 3 plus 1? And that's 4. 2 times 3 is 6. 3 times 1 is 3, and 6 plus 3 is 9. So the point 31 is the only point that will work for both equations. Then let's look at number 2. So again, to solve this system, I'm going to solve them both for y. And then I'm going to take this one and solve him for y. Be careful with your reducing. And then some people are going to be able to see this right away, but these are the exact same equations, which means they are the exact same line. So if I were to graph them, I'd go up 3 for both of them, and then down 3, right 2 for both of them. So when I draw one line, and then I go back and I draw the other line right on top of it, well, if the job is to find the point where the two lines cross, how many points are on these two lines? And again, remember, it's not just the 2 dots that you see. It's every single point on these lines. So they don't just intersect at one point. They intersect at every point. Now, it's not all real numbers, because it's not that every point is a solution. This point over here is not a solution to these lines. But all of these points that are on this line are solutions to this system. So I can't just write one answer here. The answer is infinite solutions, because there are literally an infinite number of specific points that both these lines go through. So when you solve for y and you see that they are the same line, your answer is going to be infinite solutions. Okay, so for number 3, same thing. We're going to solve for y. Careful with your signs. So I can look at the two equations I have, and again, some students are going to be able to look at this and say, well, they have the same slope, but a different y-intercept. So what does that mean? Well, let's look at it. To graph the first one, I would go down 2 and put a dot, and then up 3, write 1. And draw your line. The other one, I would go up to 4, and then I would go up 3, write 1. And draw my line. Because these lines have the same slope from 2 chapters ago, we know that that means these lines are parallel. And if my job is to find the point where the two lines cross, by definition, parallel lines never cross. So these two lines will never have a point in common as far as they go. So your answer here is no solution. There is never one point that will fit the system, that will fit both equations. So to kind of sum it all up, we have 3 types of solutions. We have when you have one point, which is when you have an x and a y. We have infinite solutions when they are the same line. And we have no solution, which are when the lines are parallel. So let's look at how they're going to ask some of this stuff multiple choice wise. It says, what is the solution to the system of linear equations that is graphed on the following coordinate plane? That's just fancy for, here's a system. I've already solved it for y for you. I have already graphed it. All I want to know is, what point do these two lines intersect? And it's right there. Now remember, it's x comma y, and x is right left and y is up down. So my x would be 2 and my y would be 0. Number 2, which point represents the solution of the system of the following equations? And a lot of people look at these two equations right here and they say, oh, well, that was nice. The first one solved for y. I need to solve the second one for y. And that's not true, because what have they already done for you? They've already graphed it. So all your job is to look at that point right there and figure out what coordinates it is. So that would be your x value would be 2 and your y value would be 1. Number 3, which point could be a solution to the system of the equations graphed? Again, it's already graphed for me. The reason I added this one is because if you can tell, each block is 2 digits. So when I try to get to this point right here, it's left 2 and then 4 and then half of another block. So it looks like it's left 5 and then up 2, 4, 6. Which point on the graph below is the solution to the following system of linear equations? Well, here's the problem. I have my system, which has 2 equations. The problem is my graph has 3 lines. So they're going to make us work for it a little bit more. And they're say, okay, I'll give you 3 lines, but you got to figure out which 2 are yours. So to figure that out, I have to solve these for y. So on this one, I'm going to subtract the 2x and get y equals negative 2x plus 2. And on the other one, careful with your reducing. Okay, so I need to figure out where he is and where he is. So the first one, the y equals negative 2x plus 2, he would go up 2, down 1, down 2, right 1. So this line right here is him. And my second equation looks like I go down 5 and then up 3, right 2. So that looks to be this line. So the 2 lines that are highlighted in red are the 2 lines in question, and I want to know where they cross, and they cross right here, which is at the letter X. How many solutions are there to a linear system shown in the graphs below? Well, these two lines are parallel, therefore they have no solutions. They have no points in common. Which system below represents the following system, or which graph? So I need to solve, this one's already solved for y, that's nice. This one I've got to subtract x. Okay, so let's test A. Let's see, I need to go down 2, which it does, and then down 1, right 2, which it does. So I like this line right here. The other one needs to go up 2, which this does, and then up 3, right 1, which this does. I like A. Number 7, it says, in which quadrant does the graph of the following system intersect? Okay, well, you need to know your quadrants. Where everything is positive is quadrant 1. This is quadrant 2. This is quadrant 3. And quadrant 4 is IV. That's quadrant 4. So I need to kind of baby graph these. So I'm going to take, this one's already done, so I'm going to take this one, this 2x plus y equals -9. Okay, so now when I graph the first one, I'm going to go up to 1, and then up 3, right 1, and draw my line. And for the other one, I'm going to go down 9, and then I'm going to go down 2 more, and write 1, and draw my line. This is not asking for the specific point where they cross, it just wants to know what quadrant are you in when they cross. Well, it crosses right here, and that's in quadrant 3. What is the solution to a system whose equations are parallel? Parallel lines never touch, so it has no solution. How many solutions does the linear system have? Okay, well, you've got to remember how to graph these two. The first one is a vertical line at 3. The second one is a horizontal line at -2. And it says how many solutions they have? They have one. They have the one point where they cross. A system of linear equations will never have two solutions. It will either be no solution, exactly one, or infinite. How many solutions does the linear system have? These two are both vertical lines. So if they're both vertical, then they're parallel, so they have no solution. They don't ever cross each other. So now we're going to take this and turn it into inequalities. And if you remember with inequalities, you have to watch out for your solid and your dotted and your shading, and you've got to watch out for when you divide by negative, you've got to flip your sign. Both of these have been solved for y, so that's lovely. The first one I'm going to go down 2 and put a dot, down 1, right 1, a couple times. Dotted line. And shade, it's greater than, so shade above. And shade lightly, I can't shade lightly, but shade lightly because that's not your answer. Those are all the solutions to the first equation. So now I got to find the second one. So the second one says go up 2, and then up 3, right 1, and solid line, and less than, so shade below. So your answer to the system is where the line is double shaded, where the graph is double shaded. So it's double shaded all in here, goes into here, and all in here. This area is single shaded, nobody's over here, and this area is single shaded, so none of that is part of your answer. So your answer is the graph because it's an infinite number of points that would work, but they are specific points, so you have to represent it with a graph. Okay, to solve this one for y, we're going to subtract x. No flipping. So to graph that one, I'm going to go up 3, down 1, right 1, solid line, and shade less than. So that's all of that. The other one's going to be a vertical line at 3, dotted. This is the only line that doesn't have above or below. It has a right and a left, and since that's greater than, we're going to the right. So the part that's double shaded is all of this right here. So that piece would be your answer. Okay, for this one, I'm going to solve for y. Okay, so I'm going to go up 3, and then down 3, right 2, and dotted line, and greater than, so shade above. And then for the other one, y is greater than or equal to 2. That's a horizontal line, solid, and greater than, so shade above. So your answer for this one is going to be all of this is going to be your answer. Any point that lies in that part is going to be your answer to your system. Okay, then we have this one, and it's an inequality, but if you can tell your slopes are the same, so the lines are parallel. And that does not necessarily mean that it's a no solution, because it depends on which way it's shaded. Again, I'm not looking for where the points cross. When it's an inequality, I'm looking for the shaded part to overlap. But remember, take into consideration that your lines should be parallel, so make sure when you draw them, you can tell that they're parallel. So the first one, I'm going to go up to 1 and put my dot, and then up to right 1. It's a solid line, and greater than, so I'm going to shade above. And the other one, I'm going to go down 2, and then up to right 1, and I'm solid. And again, make sure you draw them so that they're parallel. And that's less than, so I'm going to shade down. And so you can tell from this that the shaded part does not overlap, so your answer is a no solution. But think about it this way. What if this line was shaded down and this line was shaded up? Then your answer would be the part that's in the middle. So again, just because they're parallel when it's an inequality does not mean that it's a no solution, but it is in this case. So number 5 is really interesting because a lot of students say, oh, it's solved for y, let's go graph it. But it's not asking for a graph. It says which point is a solution. So what you're going to want to do here is take each point and plug it into your inequalities and see which one gives you a true statement, kind of like what we did on the very first problem. So remember that he's an x and he's a y. So if I were to test A, and I have to plug it into both inequalities, so I'm going to try the first one. So y, which is 4, is greater than x, which is 1, minus 2. So all I'm doing is I'm taking my x and my y and plugging them into the first equation, my 1 and my 4. And then 1 minus 2 is a negative 1. And so then you have to ask yourself, is 4 greater than a negative 1? And yes, that's true. So he gets 1 check mark. But he's got to work for the other one also. So let's test the other one. So start with the y. So that would be my 4. Less than or equal to negative 3 times x, which is 1, plus 1. Is 4 less than or equal to a negative 2? No, that's false. 4 is greater than. So he gets an x. So he's out. So now let's test B. So he's x and he's y. So again, we're going to go into the first one, this top one. So my y is 3. My x is 0. So is 3 greater than a negative 2? Yes, yes it is. So he gets a check. So let's see if he passes the test on the second one. 3 is less than or equal to negative 3 times 0 plus 1. So 3 is less than or equal to 0 plus 1. And is 3 less than or equal to 1? No. So he's out. So let's try C. C. He's X, he's Y. Again, we're going back into the top one. So 1 is greater than negative 2 minus 2. Is 1 greater than a negative 4? Yes. Okay, let's plug it into the second one. 1 is less than or equal to negative 3 times negative 2 plus 1. That'd be 6 plus 1. That's a 7. Is 1 less than or equal to 7? Yes. So he's our winner. He is the one point that works for both inequalities in this system. Which graph shows the solution to, okay, so this is not a system, this is just an inequality. I need to solve for y. So I need a y-intercept of 3, like that, but my slope is negative 2, which means down to right 1. So A is out and B is out because they don't go down to right 1. So let's look at C and D. Both of them go up to 3, and both of them go down to right 1. The difference between C and D is which way they are shaded. So if I look at my original problem, it's less than, and less than means shade down. So the answer will be D. Number 2, which inequality is graphed below? So this is a vertical line, so I know it's x equals, so these two are out. It's shaded to the right, which means it should be greater than. Less than would be shaded to the left. Number 3, which linear inequality does the following graph represent? Well, none of these are solved for y, so a lot of students get really discouraged and they'll just guess. But if you'll look really carefully, the difference between A and B and C and D is A and B should be a dotted line and C and D should be a solid line. Well, which one do we want? We want a solid line. So A and B are out. So now I've got it down to two inequalities. So just take the first one. Divide by 4. All right, so let's check them out. Up to 2, down 1, right 4, and less than shade down, yes. So he's my answer. Which point is not a solution? That's a very easy word to overlook. So if I'm testing points, I'm plugging them in and seeing which one works, but I want which one is not a solution. So 3 of these are going to work, and I want the one that does not work. So again, remember this is x and this is y, so I'm going to plug the 10 in for my y and the 4 in for my x. So if I'm testing A, I'm going to have 10 is greater than 4 plus 4. And is 10 greater than 8? Yes, that's a true statement. So he is a solution. So he's not the one I want because I want the one that does not work. B is going to be 8 is greater than 3 plus 4. And 8 is greater than 7. So he's out. So let's test C. 7 is greater than 2 plus 4. And 7 is greater than 6. That's a true statement. So he's out. So now we test D. 5 is greater than 1 plus 4. Well, is 5 greater than 5? Well, this one's tricky. No, 5 is not greater than 5. Well, how could you change it so that that would be a true statement? If you put an equal to underneath here, then that is a true statement, but that's not what we have. We have 5 is greater than 5, and that's a false statement, so that's the one I want. Number 5, multiple choice. Identify the system whose graph is shown below. Okay, well, the first thing I notice is that one line is solid and one line is dotted. So let's figure this out. The one that has a y-intercept of 1 should be a solid line. So y-intercept of 1, solid line. Looks like all these that have a y-intercept of 1 is a solid line. And the one that has a y-intercept of a 3 should be a dotted line, and they all have that too. So that doesn't help me at all, but it was a good place to start. So now let's talk about where we want to shade. Well, for the dotted line, for me to get here, that would be shaded above. And for the solid line, for me to get in here, that would also have to be shaded above. So I want to be shaded above for both inequalities. So which ones have both inequalities as greater than? And the answer is B. The graph below shows the solution to which system of linear inequalities? Okay, well, these unfortunately are not solved for y. So you could look at it as in you have to solve each of them for y. But again, I noticed that I have one solid line and one dotted line. I can see the solid line going through a 4 and the dotted line going through a 6. So solid through a 4 and dotted through a 6, that looks good. This does not. This is going to be a dotted line with a 4, so he's out. That looks good. This does not, because that's a dotted line with a 4, so he's out. So let's test A. If I were to subtract x, and then I would have to divide by -1. Okay, so let's test them. So does it go up to 4? Yes. Slope is 1, so up 1, right 1, up 1, right 1. Yes. Solid line. Yes. Less than, shaded below the line. Yes, absolutely. So I'm really liking that equation right there. So let's test the next one. X plus y is less than 6. Okay, so y-intercept of 6. Yep. Slope is -1, down 1, right 1. Yep. Dotted line, yes. And shaded below the line, yes. I like A. Which of the following represents the system shown in the graph below? Okay, it looks like I've got a dotted line going on right here, but I've got a solid line right here, and that one's perks my interest because that's going to be a vertical line, so that's going to be x equals. It's a solid line, so I know he's out. That's an equal, so there's nothing shaded. So both of these I like. I want to be shaded to the left, obviously, so I want less than. So that would have to be D, because this is greater than. So I didn't even really have to address the other line. I could figure that out all by the vertical line. So number 8, let's see if we can kind of do the same thing. It's really easy to see this line right here. And very easy to overlook that you have a line right here because it's right on the axis. The reason I know there's a line there is because you can see how my shading stops. So these are my two lines. Well, let's talk about this line first. So it's horizontal, so that's going to be y. It's above, so I know it's going to be greater than or equal to. So this one's less than, so he's out, and this one's less than, so he's out. So then if I look at B and C, if we check out B and I subtract x, then my y-intercept is 0, down 1, right 1, yes, and this is shaded greater than, which should be shaded above, so yes. Number 9, choose the system of linear inequalities shown in the graph. So these are obviously parallel lines, so they need to have the same slope. The answers that stick out to me are C. Their slopes are 1/3, and that means that from here we would go up 1, right 3, which we do not. So he is out. All right, let's test this little guy right here. So his y-intercept is a -1, so I'm looking at all my equations that are -1. He goes up 3, right 1, and should be shaded greater than. So if I'm looking at this one right here, that's shaded less than, so he's out. That is also shaded less than, so he's out. That's shaded greater than, I like that. And then this line right here should be shaded less than, which he is. So I like D. Number 10, the graph of x is greater than 0 and y is less than 0 consists of all the solutions into which quadrant? Well, again, remember, this is not just the lines. This is the shaded part. So x is less than 0 is going to be a vertical dotted line. Greater than 0 is going to be shaded to the right. Y is less than 0 is going to be a horizontal dotted line. Less than is going to be shaded below. So the double shaded part is all in here, which is which quadrant? If you remember, it's 1, 2, 3, 4. So this is quadrant 4. Number 11, it says in which quadrants are the solutions to the system. So it wants to know which quadrant it's in. Okay. So first thing I have to do is solve for y. So I'm going to add x And this one I'm going to subtract x. So I need to graph both of these. I'm just going to kind of baby graph them. So I'm going to go to 0, and then I'm going to go up 1, right 2, solid and greater than. And then the other one, I'm going to go up 3, and then down 1, right 1, and solid, and less than, so shade down. So if I'm looking at the double shaded part, it looks to be all of this, which looks like it gets quadrant 2 for sure, quadrant 3, and then if you look right in here, it also hits a little of quadrant 1. So 1, 2, and 3. So just be really careful and take your time and do a little baby graph, or graph them big on a separate sheet of paper. Either way is fine. Okay, so for number 12, it says which point is a solution to the system. So when they give you a point, this is when you plug them in and find the one that works. So to save time, I'm just going to show you the one that works so you can see what it looks like. And then I'm happy to show you one that does not work so you can see what that looks like. So I'll show you. A does not work, so I'll show you how. Remember, that's x and that's y. So if I plug it into my top equation, my x is going to be a -2. My y is a -4, so minus a -4. Plus plus, so that'd be 2 is less than 5, which is true, so he gets 1 check. But then the next one is a -4 is greater than or equal to -2 times -2. And -4 is not greater than or equal to a 4, so he does not work. So A doesn't work. The answer is B, so let's see how that one looks, because he works. Remember, he's x and he's y. We're going into our top equation. So x is 3 minus my y is -1. 4 is less than 5. Yep, true. Okay, let's take the same point and plug it into my bottom equation. So my y is going to be -1. -2 times 3. That'd be -6. Is -1 greater than a -6? And the answer is yes, because it's less negative. So B works. Number 13 is the same type of problem. Answer there is B. Take your time. If you want to pause this and work this one out, you're welcome to try that. But the answer there is B if you want to work it out. Number 14, it wants me to graph, so I'm going to take both of these equations and I'm going to solve them for y. Now you have to be careful with inequalities, because if you divide by a negative, you have got to flip your sign. So make sure you watch out for that. And the other one, much simpler. So I'm graphing that guy and that guy. So I've got one solid and one dotted. This is hard to see because this is these are my axes. This one's not shaded at all, so I know he's not it. Okay, now don't look at B and think that B is wrong just because it doesn't have the extra shaded part. When it only has one shaded part, it's assuming that that's the part that's been double shaded. So if I'm going to look at this equation, I want to go down 2, which this one does, up 1, right 2, which this one does, solid line, which this is, and greater than, so shade above, which this one is. So far, so good. To take my next equation, I'm going to go up to 3, which this one does, down 1, right 1, yep, dotted line, yes, and greater than, so shade above, absolutely. Answer's A. Number 15, which graphs is the solution to the linear inequalities? So we need to solve both of these for y. So I'm going to subtract my x. I'm going to divide by -1, which means I have to flip my signs. And then the other one's much simpler, so I have to add 6. Okay, so let's look at A. This one's going to go down 2. Yep. Slope is 1, so up 1, right 1. Yeah, I like that. Solid line, yes. And greater than, shaded above, yes, absolutely. This next one, I need to go to 6, which this does. Down 2, right 1, yes. Solid line, absolutely. And shaded less than, and this is shaded less than. So answer's A. It's really nice when the answers are at the beginning and you don't have to work all of them out. Okay, so this next one, so I have to solve for y. So the first thing I'm going to do is subtract x. And this one, I'm going to add x. Okay, so the first one, I want to go down 3. So down 3. And down 1, right 1. Yep, solid line. Yes, and it says less than, so shade below. No, this one's not shading below. So A is out. B looks to have the same line and be shaded below. So I like that. Let's test the other line. So he would go up to 3 and then up 1, right 1. Solid line, and he is also less than, so that would be shaded below. And yes, that would produce this as my double shaded part. So the answer is B. Last one, number 17, says which ordered pair is the solution to the system of inequalities shown in the graph? So normally this is where we would plug our points in, but because it's already given me a graph, all I'm going to do is figure out which of these points is in my double shaded part in here. Now remember, points on this dotted line do not count, but points on the solid line do count. So let's take our first point, 0, 3. So that means left, right, 0, and down 3. Really hard to see, but I think he's right there. So I think he's good. Let's try the 2, 0. 2, 0 would put me here on that dotted line, so he does not count. 3, 0 would put me out here, which is just in the single shaded area, which is not good. And 8, 2 is going to put me way over here in no man's land. So the answer there has to be A. Again, feel free to stop, rewind. I know this is a lot of information, but the nice thing is you do have it on a video, so you can stop and slow it down and rewind it and listen to it again and do whatever it is that you need to do so that you are comfortable with solving a system by graphing.